This video is about optimum weight charge and utilization of a Uniflow powder meter, if it's feasible or not for the average reloader who wants to have a good accuracy load. There's an article on the internet by Dan Newberry, and you can see here the website that it's at, and it talks about optimum charge weight. I took a precision rifle class over the past summer, and I used federal premium ammunition, and I was so impressed with that. But yet at the same time, it's fairly cost prohibitive if you want to do any amount of shooting. So I have been reloading for many years, but never going out there 600 yards trying to keep things very accurate. So for reloading can save a lot of money, but at the same time, how is it that federal was so able to get such a good load, and that had evaded me? I've been working on reloading for accuracy for quite a bit. So read this article and applied it. So I went through just on a basic 308 Winchester using a Lake City match brass, military brass, using bench rest primers, the CCI bench rest primers, and an IMR 4895 powder. So why did I choose the IMR 4895 powder? Really, it was kind of reading around a bit. It doesn't seem like it's the best powder. A lot of people had a lot of opportunities with Varget, but with the reloading and supplies as they are, the inability to get some of those powders, IMR 4895 seemed like a good option. So I also went with the Sierra Matchkings 175 grain boat tail hollow point, just because that is, again, the bullet that was used in the federal premium ammunition. All the loads that I developed for this testing they were all seated at a 2.8 inch overall length. The rifle, just basic Remington 700 with a heavy barrel and 1 in 10 twist. Just a decent quality Leopold scope on it and a Harris bipod. Went through and loaded up some ammunition. Here you can see the different charge weights that I loaded. Now, one thing I did not cover in this was I did a previous test this past summer using some of the same principles, but what I found was the information I had was pretty hot, and I started seeing some case pressure issues, and I never found a decent load like the article talked about. So what I did is I went and did some more evaluation, looked what other pet loads people had, and then tried to redevelop based on that. So I loaded up 3 rounds of each of these charge weights. So when I went out to the range, I warmed up the barrel with 3 shots on a target. It was pretty early in the morning. The density altitude was minus 2,200 feet. It was 25 degrees outside, and I also let the ammo cold soak in that weather to bring the cartridge and powder temperature down. Also, part of the testing, if you read the article, was to shoot in a round robin. So effectively what you do is you take your one load, shoot one target, go the next charge up, shoot the next target, and you do that to randomize your data. So if you start developing shooter fatigue at the higher loads, maybe it's the higher loads that's causing the inaccuracy, but it could also be shooter fatigue. So by splitting it up, you kind of split up that problem. You kind of blend that information out. You can see here the targets that I shot. So the sequence was target 1 was the lightest load, 2, 3, and 4 as we work our way up. Then it went to 1-2, 2-2, 3-2, and 4-2. One thing that kind of surprised me was and this is fairly consistent with this rifle, every time I've done load development, as you increase velocity, you also increase or you decrease the elevation. The bolts want to go down with velocity, and I'm assuming there's some barrel harmonics going on there that are doing that. Otherwise, it doesn't make a whole lot of sense. So the net result was, if you look at targets 3, 4, and 1-2, you can see that elevation-wise, those are grouped in both the same position, same relative position, and they're decent groups. Target 1, 2, there's some horizontal motion there that I wasn't real happy about, but again, I have it on a bipod and I have the rear bagged, so it should be pretty stable horizontally. I'm going to chalk that up to shooter error, the horizontal portion of it. So looking at those three weights for 3, 4, and 1-2, it was 41.3 grains, and then the high was 42.1. And per the article, trying to find three that fall in the same range, that gives you that forgiveness in your charge weight that will allow you to still hold good accuracy, but at the same time not have to have that insane consistency in your powder charge. So basically picked a load of 41.7 grain because that was the center of that range, and it did hold a very nice group. So for the verification test, I went back, loaded up 20 rounds at the 41.7 grain, again using the standard practices that I used on the other loads. Went out to 600 yards and started shooting. I did 3 shots to warm up and to sight in. The temperature was 32 degrees that day, minus 1300 density altitude, and I had a 6 mile per hour crosswind. To compensate for that, for both the distance and the crosswind, I came up 16.5 minutes in up compensation and 3.5 minutes left from my 100-yard 0 point. So I went and shot at a, I believe it's a 30 by 30 inch target, 5 shots, and you can see that group here. The results of it was a total spread of 5.5 inches. So a 1 MOA would be 6-inch group at 600 yards. So I felt pretty happy with it. You know, not that it couldn't be better, but again, based on the distance and everything, it seemed to do fine. One thing to note is that I should have, based on the target, you can see where the bullseye is, I should have been another half a minute left and another half a minute up for compensating. So that gets into where I am right now and why I'm doing this. Is there's the Rcbs Charge Master 1500, which is around a $300 to $350 precision measuring device. They claim plus or minus 0.1 grain load accuracy. You put the powder in, you push a button, it automatically weighs out the charge. So do you need it? Would it help? Or would the uniflow be fairly consistent? So what I did is, again, I do the powder trickler method, but that's horribly time consuming, where you throw a charge and then you trickle it in. So I set up my uniflow powder measure with the IMR 4895 powder, looking at the graph here, this is the order in which the charges were weighed. Pretty consistent. Two flyers, one high, one low. One got down to 41.3, the other one got up to 42. So then this is what's called a histogram. So I basically, it shows kind of where these weights are falling in. And you can see there that one flyer, the 41.3, and then other than that, it's fairly well grouped around 41.7. So the results of this test for the nerdy engineers out there, the average was 41.7 grain of powder, max 42, min 41.3. Looking at a standard deviation of this being a population, 0.101 grains. So the standard deviation, to set the upper and lower control limits, I applied the 3 sigma rule, so that set my upper control limit at 42 and the lower control limit at 41.4 if I round up from the 41.39. So what does that really mean? Statistically speaking, what that means is that 99.7% of the charges that you throw will fall between the 41.3 and 42 grain of powder. Now that's a pretty big variation when you think about it. That's 0.7 of a grain total swing that you could have. Again, looking, if you remember that histogram plot, most of them were the 47, 48, and then they significantly tailed off as you went higher and lower, both. But that's kind of the point of the test. So now what I've done is I've loaded up 10 rounds at each charge weight. So I went through, loaded up 10 rounds at the 41.4, 10 rounds at the 41.7, 10 rounds at the 42.0 grain charge weight, and we'll see how they shoot to evaluate the accuracy that we need to that is required in the powder dispensing. Okay, so now I'm going to show the importance of consistency when using the Uniflow powder measure. If you notice, I've weighed out a charge. It is right now at 41.8 grain of powder. I'm going to discard that. If I am nice and consistent in my motion, it'll be, again, based on the data I have, fairly consistent. That one is maybe a little bit light. We can adjust it 1/10 of a grain there, and that's pretty spot on. So that's 41.7. Now, on the other hand, if I go and if for whatever reason I tap it a couple times, that lets that powder settle down in the bottom of the metering device. If I measure that, you can see it's going to be significantly higher. So in this case, we'll get an exact measurement there. So I went from 41.7 to 41.8 all the way up to 42.8. So I've added an entire grain of powder by being excessively rough with the powder measure. But again, that just shows the sensitivity with the powder flow and how, if you're going to utilize this, you have to be very consistent with how you handle it. So just to show, I'll go back and do a normal measure. And you'll see it's considerably light, so I will dial it to kind of where I expect it to be. And it's right on the 41.7 where we started. So again, inconsistent charging handle action will give you inconsistent results if you're not careful. For all the loads that I worked up for this experiment, I actually threw a charge slightly less than what I wanted. Then I used what's called a powder trickler. All it is you put a small amount of powder in here, and as you turn this screw, it slowly dispenses powder into there so you can get the precise amount. So if you can watch, it doesn't take a whole lot of powder, and you can see that beam of that scale raising up. And that's how I was able to feel very confident in getting a very accurate load when I was loading my center and then max and min charges for the testing in this video. So each charge was weighed out this way. It takes a long time, and that's why I'm doing the testing. Is this really necessary to go to this much detail for the type of shooting that I'm going to be doing? So the current conditions for shooting were 22.6 degrees. I had a mild 3-mile-per-hour wind coming straight at me. It was 1,760 feet below sea level density altitude. It was snowing, unfortunately, and I was at a 300-yard range. Okay, it's shooting day. This is my rifle, just a Remington 700. I've got the chronograph set up about 15 feet in front. It is snowing today, a light snow, so we'll see how we do. Targets are down there 300 yards out. I have a spotting scope set up to take video of it as I shoot. So the following video is the sight in. So I was at 300 yards, fired 2 shots, did an adjustment to try to bring it more towards 0, and then fired the third shot at the top of the silhouette. The following video is of the actual shooting. Initially I thought we'd be able to see the bullet impacts, but with the snow and visibility issues, it really compromised being able to watch that. I did not shoot as fast as it shows. I trimmed out some of the dead time in between the shots, so I didn't really shoot that fast. Probably on average every 45 seconds I fired a shot. So this is the target from the first load weight of 41.4 grain of powder. As you can see, 2 of them are right in the dead center. One of them is significantly further away and low. This is of the middle weight, the 41.7 grain target. And again, you can see here they're pretty centered around the bullseye. Finally, the 42 grain load you can see is pulled left of the target of the bullseye, but centered fairly well for elevation. If you look at the combination, I plotted this out on a graph so we could kind of overlay them. Overall, it appears as if with the additional grain weight of powder, it's moving slightly to the left. With the conditions that I was shooting in, it made aiming somewhat difficult to really get a good crisp picture. So I'm not convinced that some of these shots aren't a little noisier than what they should be, but nevertheless there is a trend there's an apparent trend that the shots moving from the low to the high grain weight are moving left to, or right to left. So the results, the 41.4 grain group was 1.875 or about 5/8 MOA. The 41.7 group was 2.375 or 0.8 MOA. The 42 grain group was about 1 1/8 inches or about 3/8 MOA. When you look at the overlay of all three over on one target, it was about 3.5 inches, so just over 1 MOA at 1.2 MOA. So the conclusions, the unifold powder meter really works well. It's consistent, or consistent enough for what I'm doing. I'm not going to be using a trickler in the future unless I really want to do some very precise loads. There's not just a whole lot of benefit to it. Another option would be to weigh each charge afterwards just to verify that I don't have any real flyers. Again, if you remember back in the video ways, there was a couple flyers, both low and one high. That could eliminate at least some of that and keep the speed up. Moreover, at the end of the day, I'd like to repeat the test with some better weather. I still have some rounds left over from what I loaded up that I'm going to save, and maybe when we get to maybe a little bit nicer weather, go out and repeat it and make sure that everything's good there, and it'd give me another data point. So I appreciate you watching this video, and have a great day.